Hello guys, am I audible to you? If I am audible, then let's get started our video. Today's topic is on uniqueness of limit. We have discussed in the section of series and sequence that a sequence cannot have more than one limit. Like that, uniqueness of limit on sequence, that is also same as uniqueness of limit of, now this is function. So this is the theorem. We are going to prove this theorem, that uniqueness of limit of a function. Okay, we are going to prove. In this video I will prove it, and before proving this statement, before proving this theorem, I hope you watch my previous video on the topic limit point and limit also. So if you have watched the previous video on the topic limit point and then limit, then please come to this third lecture. This is the lecture number 3. This is lecture number this is 3. This is not only for BSc third semester, this is for all BSc student. This is for all BSc student, BSc mathematics student. So they have to learn about this topic. Okay. This theorem says if f is a function from a subset R to R, that means f is a function from A to R, but A is a subset of R, and a real number C is a cluster point of A. Cluster point, limit point दोनों same ही है. Okay. Then f has only one limit. हे function to limit at C. ये जो पॉइंट C है ना, वहाँ पे इस फंक्शन के सिर्फ एक ही लिमिट होगा. At this point C, f cannot have more than one limit. Okay, this is the theorem. So we will prove this by taking two limits, L and Ls. Let's start. Prove. Let f from A subset R to R, C is cluster point of A, and f has two limit at C. Say f has two limit at C, say L and L dash. These are the limit. Now from the definition of limit, what we get? We get when L is the limit point of f at the point C, we get modulus of f of x minus L less than epsilon. Before writing this statement, we have to write what we get. According to definition of limit, we get what is when a real number L is said to be limit of a function f. For if the definition is like this, if for any epsilon greater than 0, if for any epsilon greater than 0, there exists delta greater than 0, such that if modulus of x minus c greater than 0 less than delta, then modulus of f of x minus L less than epsilon. Okay, so we assume Hence, we have assumed that L and L dash are two limits of this function f. So, for epsilon greater than 0, there exists delta. For epsilon, there exists delta. If you give me epsilon, I will give you delta. If you give me epsilon, I will give you delta. That means, what is the matlab? Matlab क्या होता है? Matlab, delta is dependent on epsilon. Okay, whatever the epsilon may be, I will give you delta. That is dependent on epsilon. If it is dependent on epsilon, it will be dependent on also epsilon by 2. This is a construction, delta of epsilon by 2. This is a construction. You will have to know, you will come to know why we have construct this like this. Okay. For any epsilon greater than 0, there exists delta of epsilon, that with delta depending on epsilon by 2, such that because there are two limits, so we have divided epsilon by 2. For this time, you keep it in mind, okay, like this. For epsilon greater than, there is delta greater than delta of epsilon by 2. This is also greater than 0. Delta greater than 0. There exists delta depending on this, which is greater than 0. This is greater than 0. Such that if modulus of x minus c greater than 0 less than delta, whenever this, if this, then modulus of f of x minus L less than epsilon by 2. Okay, for any epsilon there is delta such that if this, then f of x minus L less than epsilon, f of x minus L less than epsilon. But we have written here epsilon by 2. We can write also epsilon by 2. If epsilon is greater than 0, epsilon by 2 is also greater than 0. It is a positive number. However small may be, however large may be. This comes from my lecture number 2. That means this, if you have watched my lecture number 2, then you can write this construction. This comes from the definition of limit. When L is the limit of this function f, then we have get this. And when L dash is the limit of the function f, then what we get? So when L dash is limit, when L dash is limit, okay, for epsilon greater than 0, there exists delta dash epsilon by 2. This is another L dash. So for L dash there exists delta dash. For epsilon greater than 0, there exists delta dash of epsilon by 2. Delta dash of epsilon by 2. Okay, this is a construction. This is greater than 0. Such that if modulus of x minus c less than delta dash greater than 0. You can write here epsilon by 2 also. If you don't want to write here epsilon by 2, you can remove it. Okay, you can remove it. You can remove it also. This delta means delta of epsilon by 2. This delta dash means delta dash of epsilon by 2. Okay. Okay. You can write also. Okay. If this, then modulus of f of x minus L dash less than epsilon by 2. Now this both are limit, and this is delta, this is delta, and this is delta dash. Let this is delta. Okay, now you can take also, this is delta dash. You can take delta double dash. Let delta double dash is equal to infimum of delta epsilon by 2 comma delta dash epsilon by 2. What is infimum of delta epsilon by 2 and delta dash of epsilon by 2? What is the infimum of these two? Infimum, this means which is small. If this is small, we will take this delta dash is equal to delta double dash is equal to delta dash. If this is small than this, then we will take this infimum. इसका मतलब ये है इन दोनों में से कौन सा which one of this is less. Infimum of this means which one of these 2 points is less, which is smaller. The smaller quantity will be is equal to this. This will be is equal to delta epsilon by 2. If this is smaller than this will be is equal to delta dash of epsilon by 2 when delta dash is smaller than delta. Okay, this means this. Okay, we have construct this. For this delta dash, what we get? We get like this. Now modulus of L minus L dash, if they are two distinct points, difference between them is equal to 0. It's not is equal to 0. If they are is equal, L dash is equal to L dash, then difference between this L is equal to L dash, then difference between this is equal to 0. If they are if they are the same, if L dash equal to L dash, the difference equal to 0. So we are going to calculate the difference between L and L dash. If difference between this is equal to 0, so then we can say that these both are same. Okay, so we are going to calculate the difference between this L and L dash. This is equal to like this: f of x plus L minus f of x minus L dash. Can we write this like this? This f of x minus f of x, this will be cancelled out. This and this will be cancelled out. What will be remain? L minus L dash will be remain. This is same as like this. Okay, we can write this as it. Okay, this is equal to modulus of f of x minus L dash n plus minus f of x plus L. We can write this like this. Okay, what is this? This is equal to, you can write, I am writing from here, this is this, after this equation comes. Am I visible? Yeah. So if you have written this, I am going to remove this. Okay, please note down from this to this. Please note down. वीडियो को पॉज कर लीजिए और इसको नोट डाउन कीजिए. तो आई एम गोइंग टू रिमूव दिस. So this is equal to modulus of, you know, modulus of x plus y, modulus of x plus y, this is less than equal to modulus of x plus modulus of y. From this property we will this modulus of f of x minus L dash minus f of x minus L. You can write this. So f of x minus L dash minus L dash minus f of x. So minus f of x minus minus plus L. Okay. So this is here. This is x. From this minus to this is y. Then this is equal to, okay, like this is x. So this is from this to this is y. Modulus of x plus modulus of y. Modulus of f of x minus L dash plus modulus of y, modulus of minus f of x minus L. And this is equal to, now I will remove this. Okay, this is equal to modulus of x plus modulus y. This is equal to modulus of f of x minus L dash plus modulus of this minus modulus of minus x is equal to x. So modulus of f of x minus L. I will remove this. Okay, and this is less than modulus of this is modulus of x plus y less than equal to modulus of x plus modulus of y. So this is less than equal to modulus of x plus modulus of y, and this is less than, but this is modulus of f of x minus L dash modulus of, look into here. This is 1, this is 2. Modulus of f of x minus L, modulus of f of x minus L dash, which is less than epsilon by 2. So we will put here epsilon by 2, which is greater than this quantity. Epsilon by 2 is greater than this plus this is f of x minus L, which is greater than epsilon by 2. If we are putting a greater than this quantity, this is greater than this and this is greater than this, and addition of 2 is greater than addition of 2, this 2. So this is equal to epsilon. That means this is less than epsilon. What we have finally get? Okay, I will remove this also. Okay, yeah, so finally we get, this is, we are starting from this modulus of L minus L dash. This is, finally we have get, this is here equal sign, here equal sign, this is less than equal sign, less than equal sign, this is less than, so this is less than epsilon. What we take, epsilon is greater than 0. Epsilon greater than 0. Epsilon may be 0.000001. Epsilon may be 0.000001. Epsilon may be 0.5. Epsilon may be any greater than quantity. Since epsilon is arbitrary. Since epsilon is arbitrary, so modulus of L minus L dash is less than any positive number, less than any positive number, however small. Hence modulus of L minus L dash is equal to epsilon. 0 is equal to 0. Okay, this is equal to 0. बहुत छोटे नंबर्स, बहुत छोटा सा नंबर से भी ये छोटा है, मतलब बहुत छोटा नंबर से भी छोटा, मतलब क्या है, मतलब दिस इज इक्वल टू 0. ओके, सो दिस implies L is equal to L dash. Finally, notice here you have to notice we have get that L is equal to L dash. That means we assumed L and L dash are to different limit at the point C, but finally we get L is equal to L dash. That means इसका मतलब क्या निकला? That means the limit is unique. Whether we take L and L dash are to different limit at the point C of the function, but they both are equal. They both are equal. So if you take any two limit, this and this, finally you get this are not different. These both are equal. That means all limits at the points, or there can be have only one limit, that is L. L and L dash are equal. So we have proved uniqueness of the limit, the theorem this. I hope you understood clearly. Thank you. In the next class, we are going to discuss some problem. We are going to solve some problem regarding this topic limit. We are going to, okay. So thank you. Please subscribe my channel if you want to get the next video.